A block weighing 981 Newton, there is a block which is weighing 981 Newton. Okay, the coefficient of friction between block and the horizontal surface is mu is equal to 0.2. Okay, a vertical cable attached to the block provide partial support as shown. Okay, this is providing some sort of partial support. Okay, fine, this is providing some sort of partial support. And now a man pulls horizontal with the force 100 Newton. There is a man which is pulling in this direction with 100 Newton. What will be the tension T? What will be the tension T? Okay, so fine. Let's move on to the question. I'll be having, let's draw the free body diagram. This is my block. This is having 981 Newton here. As a result, I'll be having some sort of normal force here, right? And already there is a string which is having the tension T. Okay, and here I'll be having some frictional force F which is equal to mu dot n, right? And I also have a force in this direction which is 100 Newton. Okay, let's resolve this force one by one. First we'll move on to the horizontal force. Summation of horizontal is equal to 0. Let's see in this direction and this opposite direction. So what I can say, mu dot n is equal to 100. So what is my mu? Is 0.2 and n which is equal to 100. So what is my n? Is nothing but 500. Okay, 500 Newton. Okay, we found n now. Let's resolve the vertical forces which is equal to 0. What is my vertical force? Which was moving in the upward direction, I'm going to take it as positive. T plus n minus 981 is equal to 0. Or T plus n is equal to 981. Okay. What is my T that I need to find? Okay. What is my n? Is 500 minus 981 is equal to 0. So my answer for the T is 481 Newton. Where is 481? Is here. That's my answer. Okay. This is a very important question. Okay. A 1 kg block is resting on a surface with coefficient friction mu is equal to 0.1. There's a friction mu is equal to 0.1 between the floor and block. A force of 0.8 Newton applied to the block shown in the figure. The frictional force Ns. Okay. The frictional force Ns. Let's see. This is my block, free body diagram of the block. And this is my force 0.8 Newton. So as a result, I'll be having some frictional force which is mu dot n. Right. So I can say this is my 1 kg. So as a result, I'll be having some normal force here. Okay, first thing is, what is my normal force here? N is equal to m dot g, that is n is equal to 1 into 10, which is 10 Newton. Okay, and after that, what is my frictional force F, which is equal to mu? Mu is 0.8 and is 8, which is 8. Frictional force is 8 Newton. Fine. And what is the force which is applied here? 0.8 Newton only. So the concept here is, see, the force I am applying is only 0.8 only. Force which is applied by me is 0.58 only. But the force due to the friction is 8 Newton. So this is very high. It means the body is at rest. Even if I cannot able to move the object with 0.8 Newton. That is very obvious. It's only 0.8, but my friction is 8 Newton. Okay. Where is 0.8 and where is 8? I cannot move the object with this force. So whatever the force I apply is going to be my frictional force. That's the concept. Okay, force applied is equal to frictional force if my applied force is less than frictional force. This is very important. Okay, so my answer is going to be 0.8. That is option B. Okay.